I told you that in data manipulation instructions there are three types. One is arithmetic and logical and shift. Now let's see arithmetic first. So in arithmetic operations, any CPU should basically provide two operations at least. One is addition and the other one is subtraction. Now using addition and subtraction, we can implement everything. For example, if you have a circuit, hardware circuit, which can do only addition, then what we can do is we can write a loop, software loop, in order to convert it into a multiplication. Similarly, if you have subtraction, you can implement division. Repeated subtraction is nothing but division, right? And repeated additions are nothing but multiplication. So if you have a costly hardware in such a way that you have even multiplier and divider also as hardware circuits, then it will make things easy, and with just one instruction, instead of having a program, you will be able to divide and multiply. And these are the four basic operations that almost every computer will provide now: addition, subtraction, multiplication and division. Now using these functions, you can implement any other mathematical function like logarithm or exponentiation or all these functions. Any mathematical function you can perform. So these are actually functionally complete when it comes to implementing any arithmetic operations, right? So most of the computers are providing this. Now let's see one by one. Increment, we know it. Increment and decrement, we know it. And one good thing about increment and decrement is, in the design I'll show you again, right? But just try to understand here. A resistor is nothing but a sequence of flip-flops, and now flip-flops are connected in such a way that they are going to even act as a counter. Now since they are a counter, they are acting as counter. By supplying them a clock pulse, you can increment the value or you can decrement the value, right? So I have already shown you how to you implement a counter using flip-flops, and now register is a sequence of flip-flops. Therefore these two instructions are provided directly as a single instruction, because just by triggering the required circuits of the circuit of that counter, we can implement these two. And then addition and subtraction, these okay, one more thing. Even though I am saying that these are just one simple instruction, it doesn't mean that in just by doing one simple operation you will be able to perform this operation. No. What has to happen is, if you have to add two numbers, first you have to fetch the instruction from the memory and then decode it. While decoding it, there will be various things involved. You have to find out what is the addressing mode involved. Depending on that, you have to find out where the operand is actually present, and once you find out where the operand is present, then only you can fetch the operands, and then you have to perform the operation. In order to perform the operation, you have to the actual circuit, the hardware circuit will come into picture in the arithmetic logic unit. So before providing the inputs to this arithmetic logic unit or the hardware circuit, we have to do a lot of things. Therefore, even though I am saying that they are simply one instruction, there are various steps involved in this, and all those steps are called as, generally the name is micro operation or micro instruction. So later when I am discussing about the design, we will again get into those. So for now, even though I am saying that it is simply one instruction, it is not actually one instruction. It involves a lot of phases. We shall get into that slowly. Okay. So addition you know, and subtraction you know. Multiplication is normal multiplication and division. But the problem here is, it is not just about the addressing modes. Apart from this, the numbers are also various types. So which means sometimes we are trying to add two integers, sometimes we are trying to add two floating point numbers. So depending on them, we might have to have different instructions as well as different hardware circuits also. Therefore, most of the computers, they provide various versions of each instruction, right? So each instruction will vary depending on, one is addressing mode and the other one is type of data. For example, adding two integers is different from adding two floating point numbers. We need a complete different circuit. and also we have to decide about the precision. The precision is nothing but the symbol. Let me explain you. Let us say a register is having n bits. Now using n bits we can represent only 2 power n numbers, because we have 2 power n different patterns and each number can be represented, or if you give one pattern to each number, we can only represent 2 power n different points in the number line. But then if you see the real number line, it has got infinite number of points. Therefore we cannot cover all the points in the real number line using 2 power n combinations. So what we do is we cover some of them, and if the result happens to be present in these two, in between these 2 points which we have covered, then we have to either show that the result is this point or this point, right? Now the difference is called as precision, right? Which means we cannot accurately represent every number, but we'll give a close approximation, right? And also depending on what type of approximation you want, again the instructions will get multiplied. Therefore even though I am just writing a small category here, or in small in a brief manner, if you look at the manual of any computer, you will see hundreds of instructions related to just, let's say, addition or subtraction. You will see hundreds of these arithmetic operations. Even though the basic operation is simple, because of all these addressing modes and types of operands, you are going to get hundreds of instructions. But then we are not going to implement all of them in our examples. I'll just take a subset of them and implement it. Okay, for now just focus on what is being done here. And the next one is add with carry. So what happens is we'll have a special flip-flop or a bit called as carry and a bit called as borrow, right? So whenever we perform an operation, sometimes we might get a carry, and for the next operation we might have to use the carry which is generated in the previous operation and add along with that. Which means, let us say you have just performed an operation c equal to a plus b, something like this. Now by this addition we have generated some carry, and next time when you are performing in next addition, let's say c equal to a plus d or something like this, we might have to add this carry to this, and we might have to add all these three and put them in c. So for that reason some special type of instructions like add with carry will be useful. So what does it mean? Whatever is present in the carry, take it and add along with the operands. And the next one is subtract with borrow. So sometimes whenever we subtract, a borrow might be produced, and next time when you are subtracting, we might have to subtract along with the borrow, right? So that is called as subtract with borrow. And the next one is negate. So negate is nothing but taking the getting the negative number. If you have 10, you are supposed to get minus 10. So it is nothing but 2's complement. So for implementing 2's complement also, we might have a hardware circuit, and in order to send the operands to that circuit, we might have to use this instruction, right? So these are the brief overview of all the types of instructions possible. But when we get into details, each instruction will give rise to lots of instructions. Okay, so if you see the manual, you will see hundreds and thousands of instructions just for arithmetic operation. To just keep the thing simple, we have taken only few examples. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.